Welcome to Let's Get to the Marks. We're looking at AQA Chemistry A-Level, Aldehydes and Ketones. That's the MCQ question paper. You find this on the awesome Physics and Maths Tutor website, which should be familiar to all biology, physics, maths and chemistry students. Question 1. How many structural isomers with the molecular formula C5H10O react with Tollens reagent? Is it 3, 4, 5 or 6? You should know by now that Tollens reagent is the one that forms a silver mirror with aldehydes. So we're looking at essentially how many aldehydes or aldehyde isomers can we make from C5H10O? So let's go. The first one I've written here is pentanal. Okay, so I'm just putting all 5 carbons in a straight chain. Remember, the aldehyde group, the carbonyl group with the little hydrogen coming off of it, can only appear at the end of the molecule. So that simplifies this a little bit to us. Okay, so we could do 4 like butanal, and then stick one of the carbons, the 5th carbon, on the 3rd carbon. This should be 3 methyl butanal. Awesome. Okay, now we could move that methyl group 1 along to make it 2 methyl butanal. Oh, I messed the names up. Never mind. I'll flip them around. Sorry about that. That was 3 methyl butanal. I could move the methyl group 1 along so that it's right next to the aldehyde group, and it will now be 2 methyl butanal. So I've got 3. So is that the answer? Well, let's have a look if there's any more we can make. We got 5 carbons. We can make that kind of star shape by doing a propan chain and then put in 2 groups coming off the middle. And this is 2,2-dimethyl propanal. And that is going to be our last one there. So there you go. The answer is 4. There are 4 possible molecular isomers that can react, structural isomers of aldehydes that can react with Tollens reagent. And the answer to the first question is B. Question 2. Which alcohol could not be produced by the reduction of an aldehyde or a ketone? So if you have an aldehyde or a ketone, as you might remember, you reduce them. You can use NaBH4 to reduce an aldehyde or ketone, and you get the hydride ion joining on to the delta positive carbon on the carbonyl group. So aldehydes and ketones can be reduced. Aldehydes are reduced to primary alcohols, and we know ketones are reduced to secondary alcohols. So they're saying which one of these couldn't have come from an aldehyde or ketone. They're all alcohols, A, B, C, and D. They all end in ol. So it has to be the one that's a tertiary alcohol. So hidden among these answers, oh my gosh, hidden among these answers is a tertiary alcohol. So let's find out. Sorry, I don't know what happened to the sound there, but let's get in and locate which one of these is a tertiary alcohol. And what I'm going to do is go through the detail and explain why the others aren't. Let's get on and draw these out. So the first one up is 2,2-dimethyl propan 1-ol. So I like to start with the chain, the propan. So we've got 3 carbons in the main chain with a hydroxy group on the end. And we've got coming off of the 2nd carbon 2 methyl. Oops, why did I put the hydroxy group there? That is incorrect. Boom. We got 2 methyl groups coming off of there. And then we have hydroxy coming off the propan. This is a primary because there's 2 hydrogens attached to the alcohol carbon. Let's look at 2-methyl-butan 2-ol. So we draw the butan chain. We've got a methyl group coming off of the 2nd carbon, and we've also got the hydroxy coming off of the 2nd carbon. So let's zoom in. There are no hydrogens attached to the carbon that the alcohol group's on. So this is a tertiary alcohol, and that is our answer B. I'll draw the others out for you. So here's C. You can see 3-methyl-butan 2-ol. The hydroxy has 1 hydrogen coming off it. It's a secondary alcohol. And then if I draw pentan 3-ol, we'll be able to see that that is also a secondary alcohol. Have a little look. There's the OH, and that has a hydrogen attached, which means 1 hydrogen attached to the carbon with the hydroxy. It's a secondary alcohol. So we found the answer's B. Let's move on. Let's get into this question number 3. Which compound forms a racemic mixture when reactive with KCN, potassium cyanide, followed by dilute acid, which gives us some hydrogen ions? So the racemic mixture has an equal amount of each enantiomer. Enantiomers are molecules with a chiral carbon that can form mirror images of themselves. So we're looking now, this race mix mixture is formed when a nitrile is attacking one of the compounds A, B, C, or D. So we're looking really which one of these compounds A, B, C, or D will form a chiral product. So if you can work out which one of these will form a product with a chiral carbon, you've got the right answer. And a chiral carbon has 4 different groups attached. So we're really looking for A, B, C, or D. Which one forms a product with 4 groups attached to the carbon? Let's have a look. So let's draw out A. A is methanol. So we've got a little carbonyl group with 2 H's coming off of it. So we've got methanol here. It's being attacked by KCN, which means the nitrile group there, which has a lone pair and a negative sign. That's our nucleophile. It's attracted to the carbon because it's delta positive. The carbon can't have 5 bonds, so the oxygen loses one of its double bonds and we get an intermediate. The intermediate is formed, and the hydrogen from the dilute acid, don't forget we got dilute acid, the hydrogen from the dilute acid, the lone pair of the oxygen goes to it to form the bond there. So what product do we actually get? Well, we get this product here, which is a hydroxynitrile, but notice the carbon has 2 hydrogen atoms attached. What does that tell us? It's achiral. That means it's not a chiral molecule. It doesn't have 4 groups attached to the carbon. So what does that mean? A can't be our answer. Let's check out B. BCH3CHO, that's ethanol, another aldehyde. Okay, let's check this out. The nitrile, which is the nucleophile because it has a lone pair and an overall negative charge, will attack the delta positive carbon on the carbonyl group. This will force the double bond to break in order to stabilize the molecule. Carbon can't have 5 bonds. This is going to form an oxygen with a lone pair and a negative charge, and remember that hydrogen that's in the dilute acid, that gets attacked by the lone pair. And that means our final product is going to have a hydroxy group on top, a hydrogen on the right, a methyl on the left, and a nitrile on the bottom. This means it has 4 different groups. It's a chiral. It has a chiral carbon. What does that mean? There are 2 different mirror images of this molecule. It's an enantiomer, and so therefore it can form a race mixture. Guess what? The answer's B again, 3 times in a row. Let's check out the 4th question. Hopefully it's not about mirror images. I've had just about enough of that. Sorry about the robot voice, but we have a question 3 here to get on with, so let's go. Which alcohol could not be produced by the reduction of an aldehyde or a ketone? Okay, we're looking for that tertiary alcohol. Again, the answers A, B, C, D are all alcohols. Okay, aldehydes get reduced by NABH4 into primary alcohols, and ketones are reduced to secondary alcohols, and tertiary alcohols can't be made from the reduction of an aldehyde or ketone. Now let's look at the first one, 2-methylbutane 1-ol. Look at that. The hydroxy, or the alcohol group, has 2 hydrogens attached. This means it's a primary alcohol. See it there? That's right, that came from an aldehyde. Okay, let's look at the second one. We've got 2-methyl butane 2-ol. Now straight away you should notice, because you can do this quickly without drawing this all out, the methyl group is on the second carbon and the hydroxy is on the second carbon, and you should quickly be able to work out that this is going to be a tertiary alcohol. So this is going to be our answer, because we've got the hydroxy and the methyl group both coming off the second carbon. So in reality, in an exam, you could probably solve this in a few seconds, but we're just drawing out all the structures here to show you. So no hydrogens atoms attached to the hydroxy or the alcohol carbon. That means it's tertiary and can't be formed from an aldehyde or ketone. All right, guys, that means that's the 4th answer in a row. That is a B, 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 B. Yeah, all right. Maybe I should have edited that. Yeah. So, okay, I can't really big up Physics and Maths Tutor enough. It's an awesome website. It's got all the mark schemes. It's got all the exam papers. It's got revision cards. It's got the absolute stuff. All right, guys, let's get to the marks.
You're still here? It's over.